So I should have made it clear this one here is 1/3, this is 4/3, and this is 3/4, these values. It's 8 minutes, it should take a while. Maybe not for you guys. 1 minute to go. So this should say 1/4 here. And that's root 7g/30. Right, so what we have here is, notice they have a habit of calling planes pi 1 and pi 2 for plane 1, plane 2. This one is rough and this one is smooth. This one over here has a mu of 1/3. Okay, and we know that it's inclined at 10 to the minus 1 3/4. So if we draw a little diagram for that and call this alpha, then opposite over adjacent 3/4, then we have a 3, 4, 5 triangle, so sine alpha will equal 3/5 and cos alpha will equal 4/5 using this triangle. We're going to put in a normal reaction. We'll call that RA, the reaction at A. There'll be tension in this string. There will be the weight of the particle acting down, which is mg. And we know that initially held at rest, the string is taut, line goes so it's going to be, we're going to put the friction going this way. We'll call that FA. And then we're going to have tension, because it's a smooth pulley, will be consistent throughout, and it's in a light inextensible string. And we're going to have a reaction B here, and we're going to have 4 mg acting down here, and we'll call this angle here beta. So if that is beta, we're told that it's equal to 10 to the minus 1 4/3. So there's 4, there's 3, there's 5. So this time cos alpha will equal 3/5, and sine beta, sine beta will equal 4/5. And now we can set up our equations. So let's just put in some space for me to work with. And if we resolve, I basically almost do this without thinking. I resolve on B and resolve on A. So resolve on B, because there's no friction, we won't bother doing the perpendicular stuff. Okay, so we know it's going to accelerate when it's released, and it's going to accelerate, A is going to accelerate towards the pulley. So that's why I put my friction going that way. Okay. And I'm going to accelerate this way, and we know that's equal to 7g over 15 meters per second, but we want to show that. So therefore, when we resolve on B, we're going to say that 4m times A, the resultant force, will equal everything in the same direction as the resultant, which is 4mg, and if that's beta, this component of it will be sine beta. So we've got 4mg sine beta, and then we're going to have minus t in the other direction. So let's put the sine value in, and we'll get 4/5 times 4, 16/5 mg minus t. I'm going to call that equation 1. Okay, because I'm going to use that in a minute. Because I generally, when I see two things hanging off a pulley like this, you end up adding the two equations together to get rid of the t. Anyway, because we've got friction, then it's quite useful to find the reaction. So let's just resolve this one perpendicularly and find out what RA is. And the reaction is going to be equal to, well, that's going to be angle alpha, and we're going to have mg, it's going to be the adjacent part of that, so it's going to be mg cos alpha. And cos alpha is equal to 4/5. And we know that FA will equal mu RA. So we've got mu is 1/3 times 4/5 times mg. So therefore, get a bit more space to work with. We've got FA equal to 4/15 mg. Now we're going to resolve on A, and we're going to do it parallel to the plane. So we're going to have the resultant acceleration going that way. So it's not 4ma, it's just going to be ma, because the mass is just m. And that will equal everything in the same direction, which is t, minus what's in the opposite direction. So we've got fa minus this bit here of mg, which is the sine alpha bit. So minus mg sine alpha. And what we can do is we can add, we call this equation 2, and we can add these two equations together to eliminate the t values. We've got minus t here, plus t here. 4ma plus ma is going to give me 5ma. I've got 6/5 of mg. So from the minus fa, I've got minus 4/15 of mg. And then this sine alpha here was equal to, what's that, 3/5. So we're going to get a minus another 3/5 mg. So combine all those together and we can cancel out the m's. That's quite nice. And we're going to get 5a will equal 6/15, and then we're going to have, what's that going to be? 9. It's going to times that by 3. It's going to be 9/15. So we've got another minus 4/15. So you've got 16/15 minus 13/15. Oh no, it's fifths, isn't it? So let me just create some more space for me to work this in. I'm going to run out again. Let's go up here and do it. So we're going to get 5a will equal 48/15, times top and bottom of this by 3, g. Remember I had 13/15 here, g. So that will equal, when we simplify that down, we're going to take that away. We're going to get 35/15 divided by 5 will give me 7g/15, which is what I wanted. So, assume that A does not reach the pulley, show that it has moved a distance of 1/4 meters when its speed is 7g/30. So, okay, so what I'm going to do, I'm going to put u equals to 0. I'm going to put s equal to 1/4. You could have decided that v was going to equal this, one way or the other. Doesn't really matter. And you've got to show, put one of these two values in and show the other result. So we're going to put that value in and show that result. So v squared will equal u squared plus 2as. And we know that u is equal to 0. So therefore we're going to get 2 times 1/4 times by 7g/15. So therefore v squared will equal 7g/30 when I calculate all of this. And therefore v will equal root 7g/30 to show what we want. Any questions? Yeah. The 5ma. The question is, how do I get 5ma here? I've got 4ma and 1ma, adding equations 1 and 2. So I should have written here, I added equations 1 and 2 together to get this. And that's how I got my 5ma. I'm just going to rub this bit of my answer out because then I went over to here to finish it off. Any other questions? Yes. Tension is always the same throughout a piece of string, so long as it's light, inextensible, and you're going over smooth pulley. So the question was, is tension always the same? Okay, let's move on to the next question, which is another 8 marker, very similar. Let's see if you've cracked it from doing that one. Okay, so the key to this is, again, drawing your diagram. Be careful, because one of the students in my class says I just do it in my head, write out the equations without even thinking. That can lead to a painful end on your questions if you just do them without, because it looks like one I've done before, I just wrote these equations down. A very common mistake is to always assume that R equals mg cos alpha, and it does a lot, but if there's another force acting on it, it won't. Now, we've got lines of an inextensible string pass over a smooth pulley, so we're going to have tensions going here and here, which is fixed at a point in section 2 fixed inclined planes. The string has a vertical plane containing lines of slope. Pi 1 is inclined at 30 degrees, pi 2 angle theta, and what do we know? It's taut. Pi 1 is rough, and the coefficient of friction on this plane over here is going to be √3/3. Pi 2 is smooth. And they are released from less, and P begins to move towards the pulley with acceleration of g cos theta. So our acceleration is this way. Okay, so we're told the acceleration right at the beginning. So this is a rough one, so we're going to have friction P here, we're going to have reaction P here. So let's start off with the simpler one. Let's resolve on Q. So we're going to do on Q, and we're going to look at being parallel to the plane. So we've got the mass times acceleration, so 8 times g cos theta. So 8 times g cos theta, remembering that g cos theta is my acceleration, will be equal to what's in the same direction, which is going to be 8 times g cos theta minus t. I just made a mistake there, my first one of the day. It's because I'm doing parallel, it's sine theta. It's because I had the cos theta in my head from what I said previously about the r always equaling that. Okay, so we've got 8g sine theta there. On P, let's do the perpendicular part first, because we're going to need that to find the friction. Okay, so RP will equal to g, and it's going to be cos 30, which is √3/2. We know that FP is equal to mu times by r, so that's √3/3 times by the 2g times cos 30, which is √3/2. So the √3's times together to give you 3, so the 3's cancel, the 2's cancel, so FP just equals g. And when I did that the first time I did this question, I checked through that, because I always get suspicious when I get an acceleration of g. Now, going parallel, I have got the acceleration A, which is g cos theta, times by the mass, which is 2. So we've got 2 g cos theta will equal, I'm probably going to need a little bit more space, let's just move that across. So 2g cos theta will equal the tension, because that's going that way. And what's going in the opposite direction? Fp and this bit of the 2g. So we're going to have Fp, which is minus g. And we're going to be taking away 2g, and that's going to be sine of 30, which is a half. 2g times a half is going to be another minus g. So therefore we get 2g cos theta minus t, equals t minus 2g. Right, we've got our simultaneous equations. There's number 1, there's number 2. We can subtract them to eliminate, not subtract them, add them to eliminate t. So 1 plus 2 implies that we're going to have a common factor of cos theta coming out here. So let's have cos theta come out. And then we've got 8g plus 2g, which is going to be times 10g. The t's cancel. We're going to have an 8g sine theta coming from here, and we're going to have a minus 2g coming from here. And what you will notice is the g's cancel out. Now, we have got 10 cos theta equals 8 sine theta minus 2, and we simplify that, and we can see that that's just going to be the same as this one, so divided by 2. Divide that by 2, I get the 4 sine theta. Divide that by 2, I get the 5 cos theta, which I'm going to take that side, and I'm going to divide that by 2, gives me 1. So therefore, 4 sine theta minus 5 cos theta will equal 1. And we're not going to do the part B of this question because with this year's restricted syllabus, it's not on our topic list that we're going to do for this year. So next question is another 8 marker. It's the day of the 8 markers. So get ready, 8 marks, off you go. Right, okay, so let's draw this one. So we just got friction on the floor and not on the drum. So the plank, because it's, I think it said it's uniform. Yeah, plank is modeled as a uniform rod. So we've got 10G acting here, and that's going to be 3 meters long. We're also going to have a normal reaction here at B, caused by the B pushing on the plank. So those are all the forces that act on the plank, and this angle here will also be theta. So my first thing to think about doing normally is just to resolve vertically, but we want to find the reaction of B here, and actually we know this force, we don't know that force, we can eliminate those forces by taking moments. So for part A, what we can do is we can take moments about you can do clockwise or anti-clockwise, you can choose. So that's going to be clockwise moments. If I do that, I'm going to have the 10G, and remember it's the right angle component of this, which gives you your moment. So you've got 10G times cos theta. And then times by the distance, which is 3, minus the distance times RB, which is 6. RB will equal 0. And what do we know about theta? So we know that tan theta is equal to 5 over 12. So that's going to be 13. So what do we want? We want cos theta, so it's going to be 12/13 here. Okay, so we're going to have 12/13. So I'm just looking at my maths on here. I've obviously done some of that in my head. Okay, well I'm just going to write it out here in full. 12 over 13 times 3 will equal 6RB. So I'm going to divide by 6, so that's going to leave me a 2 there, and that's going to cancel there. And that isn't quite what I got. Oh, I forgot my times 3, there we go. Okay, that makes life a little bit better. So what I get is I get 10 times 2 times 3, which is 60. G over 13 is equal to RB. Thank you. One of my students pointed out I've missed out the times 3 there. So that's my answer to part A. So for part B, what I'm going to do is I'm just going to create a bit more space. And what I'm going to do is I'm going to resolve initially parallel this way. Okay, so we know that FA is going, the two forces going horizontally, so FA plus this little bit of RB are the only horizontal forces going on. Okay, all the rest are vertical, so they must be equal to each other. So if this is equal to theta, okay, this will be 90 minus theta, that's 90, so that will be theta here. So this bit, what do we want? We want the horizontal bit is going to be sine theta times RB. So FA will be equal to RB sine theta. So that will equal 60G over 13 times by sine of theta is 5 over 13. I just got asked, is the weight not also force? The weight acts vertically downwards, so it's not going to be acting horizontal at all. So we get 300G over 169 for FA. Now, if we resolve, and the reason I did that is I could see that there's only those two things, and I knew RB, therefore I could find RA. So that would save me some time. Now, if I resolve vertically, then, sorry, FA, I can find RA plus RB cos theta will equal 10G. Let's just go through the diagram on that. So you've got RA going upwards, you've got this bit of RB going upwards, which is the cos bit of this theta times by the length of RB, and then you've got the 10G going downwards, so that one plus that one will equal that one. So that's how I got this equation here. So moving on, we know that FA equals mu times RA, so therefore if we rearrange this so as RA equals 10G minus RB cos theta, then we can write that FA will equal mu times 10g times RB, which is minus RB, which is minus 60g over 13, times by cos theta, which is 12 over 13. So we got FA will equal mu 10g. Let's just write this as a single fraction. So that's going to be 169 times that. So 1690g minus 60 times 12g is another 720g. And all of that is over 169. Just gives me a single fraction. And the reason I'm going to do that is I know FA is equal to this. So I've got 300g over 169 equals mu times, now this bit comes out to be 970g over 169. And therefore I do this divided by this. So the 169s are going to cancel, the g's are going to cancel, and therefore mu is just equal to 300 over 970. Which just cancels down to leave me 300 over, not 300, 30 over 97. Any questions in the classroom? It's easy when you know how. Okay, just rolling back through all of that. Okay, so that's it for today. There will be some more of these revision sessions over the coming weeks. Do enjoy.